as principal security engineer. Before that, he was senior security architect at a leading investment institution, lead product security architect at Autodesk Inc., security architect for enterprise, hybrid cloud at Dell EMC, security consultant at the EMC Product Security Office. He is a core contributor to Safecode and a founding contributor to the IEEE Center for Security Design. He holds a master's degree in computer science from Boston University and has served as an instructor in digital forensics at Boston University and in secure development at the University of Oregon. Over to you, sir.
Thank you. So let me try and share this thing here. Where is this going to work? Okay. I should have opened this on. Just give me 1 second here. Browser problem.
That's fine. That's fine. Take your time. You've got nice background. The frame for the threat modeling.
Yeah, that's the threat model manifesto.
Yes, yes. Really appropriate for the session. Nice.
Oh, here we go. Yeah. There. The magic that is Google Chrome.
Is it asking you to select the window, Chrome window? Yeah, now we
Okay.
can. Yeah, here you go.
Let me resize this a bit more. Okay, cool. So thanks for having me here. Really a pleasure and an honor to be here, sharing this stuff with everyone. Now that Matt did the hard work, I can just slide in and do the easy part of it. So first, couple of words about me. My strange name is Izar Tarandach. I am, as was said, currently the principal security architect at Squarespace. I really like to use animated lists when I'm speaking. They help me focus on what I'm saying and not give people walls of text to look at. I've been doing the security thing for a couple of years at Autodesk, Dell EMC, RSA, IBM, a couple of startups, all that stuff. With Matt, I co-authored the Threat Modeling, a Practical Guide for Development Teams book. Also with Matt and a bunch of other people, as Matt said, I co-authored the Threat Modeling Manifesto. And we most recently presented at DEF CON 29 with the DFDs Ain't That Bad. Very important to say, standard disclaimer applies, my views are not my employer's. What we're going to see today, we're going to do a show and tell on pytm. Now, even though the title of the presentation is Threat Modeling with Code, and even though I'm wearing a black hoodie, there will be no discussions of deep code in here, so everybody can be sure that they are going to get all the points. So, a bit of history. Before we talk about what pytm is, how did it come to be? When you are working with Matt, at least twice a day you hear, wouldn't it be cool if, which is one of the best things of working with Matt. just ideas coming at you. And back a bunch of years ago, we were both working at the Dell EMC/RSA/whatever it was at the time. And we were looking into ways of popularizing and bringing threat modeling to the masses. Back at that time, we were mostly working with an approach of threat library-based threat modeling. There was a list of things that were threats that we had seen historically in our products, and we would go to product teams and ask, hey, do you have this threat somewhere in your system? And we had some people using Excel spreadsheets for maintaining their threat models. And you know what? It worked. It worked. I won't say it didn't. It worked. But it wasn't exactly the best solution. It wasn't easy to make people get close to the act of threat modeling. It wasn't easy to exchange information. It wasn't easy to visualize, and so on and so forth. Many of the things that Matt alluded to in his presentation. So we started looking at what threat modeling tools were out there. And at that time, there was a bunch of commercial tools, and Microsoft came out with their threat modeling tool, which is basically the usual Windows paradigm of moving my mouse around, clicking on things, and having things happen. And in asking people, in testing the tools ourselves, we noticed that many developers, especially those that don't work on a Windows workstation the whole day, and yeah, there are those, they came out feeling that diagrams was not the best idea for them. It was not the best solution. So paraphrasing Charles S. Harris, a coder needs a diagram like a fish needs a bicycle. Meaning, a diagram is not the thing that's going to solve everything for everybody. Perhaps you need a different paradigm, a different way of approaching the problem. Then again, the drag and drop, the cut and paste, the black lines telling me where to go one. So we came up with the idea of pytm. Wouldn't it be cool if we had something that you could use to express your system as elements in code, and those elements would have attributes, and those attributes would have values? Wouldn't it be cool if you could get out of that representation baseline threats, something that shows you where your system is right now in terms of the most popular threats, the ones that you can derive? Wouldn't it be cool if we could get diagrams? Because some people like diagrams, some people need diagrams. And to be honest, diagrams are great for documentation. Diagrams are great for showing somebody real quick, hey, this is the thing that we're working on, right? Some people absorb diagrams very quick. Wouldn't it be great if we could get a report at the end of the day, something organized where all the information is always in the same place, so that when you move from one system to another, you don't have to spend all the time parsing the format that the report came out, and you could immediately look for the information that you want where you expect it to be. Wouldn't it be cool if the threat model and the code live and evolve together? So we got together this pytm core team. Nick and Rohit at the time were with us at the EMC. John actually joined us after the project became an open source thing. And together we sort of brought it where it is today. The making of pytm, the thing that works in there, is very simple. We started with a schema, a very simple schema, that derives the parts of a system into basic elements. What's an element? It could be a process, it could be an actor, it could be a data flow, it could be a trust boundary. It basically could be anything that gets recognized as part of describing a system. For each one of those elements, we gave it a type, a name, a purpose. We have to document what those things do, and the things that it exposes, the privileges that it needs, what is it used for, what it contains. Some of those contain other elements themselves. what it connects to and what it listens to, and many other attributes that by specialization, each one of these elements has. On top of that, we put some rules, and those rules evaluate those the value of those attributes and reach a true or false result representing a finding. So we have these rules that, for example, something, the first one here, target type equals process. That basically means the element that we are looking at right now, is it a process? If it's not, then this rule has nothing to do with it. Move to the next one. But if it is, then does it need root privileges? Is it an administrator type thing? If it is, and it exposes something, we don't say what, we just say it exposes something. Then, hey, you know what? This could be a finding. There could be something here. We need some limitations around it to make sure that that thing is exposed in a good way, right? So we mark that as a finding. We present that to the user at the end with, hey, here's something that you should look at because it could be important to you down the road. And then pytm tries to organize this whole thing by providing a loader, something that knows how to read data, existing data, a parser, something that parses that data into something that makes sense, an analyzer that looks at the data in light of the rules, a renderer that produces diagrams and text and whatnot, and a reporter that actually gives you that capability of always creating the same report in the same format. Now, the way that we went about this is a bit strange because the loader basically is Python itself. The parser is basically Python itself. This is, after all, pytm, the Pythonic framework for threat modeling. So here's the roadmap of what I'm going to show you briefly. We're going to define the components of the model and the relationships between them, which are basically the data flows. Then we are going to generate a data flow diagram and a sequence diagram. We're going to annotate the components with attributes. And then we're going to generate a report that shows the threats that we have identified and present them to the user. So here's where we're going to code. This is the bare minimum necessary to write a pytm script. Now, notice what I just said. It's a pytm script. It's basically a Python script that uses pytm as a library, and for all intents and purposes, is a Python script, a normal one. That's actually the thing that we are going to call. There isn't an external tool that we are going to refer to, that we are going to load data or whatnot. We are going to run a simple Python script. So in this one, we first, as in almost every Python script, import those things that we are going to use, those structure, those objects. And in here, we can see that we are using a threat model element object, an actor, a trust boundary, a classification. We're going to talk about classification later. Data. Data itself is an element of the description of the system. We are defining data flows, a data store, a process, and a server. We start by calling out the threat model object. That's the one that's going to hold the whole thing together. And after that ellipse is in there, which we're going to fill in a second, we call tm.process. That's when everything actually happens. Thought that I erased that. So, what's in that ellipsis? In that ellipsis, we start by creating the elements of our system. In here, we are creating 4 of them. A user, who happens to be an actor, a client, which is a process, a server, which is, amazingly, a server, and a database, which serves as a data store. So you can see in here that we have an internal name used by the Python script, the name of a variable, just a normal Python variable, nothing magic about it. And we have an external name that we are going to present to the user so that people can actually refer to these things without knowing what's in the script. Then we are going to define the data flows between those elements. So you can see that, again, we create Python variables. Each data flow has a from and a to, and a brief explanation of what's going over that data flow. Now, we could make things a bit more complicated. I didn't want to, but it's possible. Instead of giving a name to each data flow, you can put a data object in there. The data object itself contains what it is, so it serves as the name of the data flow. But it also contains all the attributes of the data, like, for example, the classification, how important that data is, how sensitive that data is. So here we have 6 data flows. And when we call this simple script, that introductory line that we put in there, the definition of the elements and the definition of the data flows, we immediately get these 2 diagrams. The top one is a data flow diagram. The bottom one is a sequence diagram. Now, looking at these 2, we already are able to get a lot of information out of it. We already get a lot of added value out of the exercise, especially in this first look, the sequence diagram. Now, if you look at it, both diagrams express exactly the same information. But the sequence diagram has the added dimension of time. Time flows from the top to the bottom. So by looking at the levels of each one of the lines, we can see what came before what. On the data flow diagram, we sort of lose that right now. We don't know what's the order of the operations, who talks to whom, when. But on the sequence diagram, we get that immediately. So now, to add more to the security aspect of it, we add trust boundaries. You can refer to trust boundaries as a separation of levels of trust. So if I have a different level on one side than the other of the data flow, I'm going to put a trust boundary right there in the middle. So in this one, I define 2. I define a public boundary and a protected boundary. In the public boundary, which is uncontrolled by us, it's stuff that lives out there in the world, I'm going to put the actor, the customer. So which boundary it belongs to becomes an attribute of the user, the actor that we have defined priorly, and the process that they are using. Sorry. Why? Because those, both the actor, which is on the keyboard clicking away, and the process that they are using is probably living in their desktop, which is outside of our control. It could be argued if it was on a VPN or something that you just brought it in or something like that, or if it was in a zero trust network, you just brought that thing in. But on a normal day, people are just out there browsing sites, interacting with our servers. So our server, which is under our control, we're going to put into the protected boundary. Same thing with the database. And then we go and we express that again as a diagram. So now not only we have the data flows, we also see which data flows cross the boundaries. So those are the ones that we are probably going to take a look closely and say, hey, do I have an authentication problem here? Do I have an authorization problem here? Not that you shouldn't look at the other ones as well. Of course you should. But these are probably the first ones that are going to jump to the eye when you do an analysis of that system. Now, remember when I talked about classification back in the import thing? So here we are saying that the database, that data store that we created up there, can only get classified data up to restricted. Meaning that if you take the normal public, well-known, public or unclassified, sensitive, restricted, secret, and top secret hierarchy of data classification, we are saying that if this database is ever hit asking to store or to read anything beyond restricted level, then hey, there's a threat in here. somebody did some bad consideration and they are trying to store, to read information that shouldn't be in this database from it. So we can immediately flag that kind of threat. You can also look in this slide at some of the other kinds of attributes that we have. We ask if the server has been hardened. We check if it sanitizes its input, if it encodes output, and if it authorizes the source. Now, these, they have a very changing and different granularity. And each one of the elements has things that are common to all others and some things that are private to that type of element. We are constantly extending these attributes, and we made it very easy for the final user to add more attributes as they use pytm. Now, about that reporting thing, we have this very simple template language, and really very, very simple. We actually stole it from another open source project, but we cite it. And right now it does measure up to what we need, but eventually it might migrate into something else. Now, Judy, thank you for the comment. This is really great. One of the things that we have in mind when we thought about pytm was that even though it's written in Python, any developer that has ever seen any kind of object-oriented language would be able to not only read it, but to write it as well. Because basically we use object.attribute equals value. There's no logic involved most of the time. There are some very, very, very edge cases that might use it. But we are basically describing, modeling that system, as Matthew talked about, in very simple terms. You can imagine it as if you are actually dragging and dropping boxes around and then clicking on them and filling dialogues, but you are actually doing it textually. What that report language gives us is the ability to produce reports like this. Things that have the diagram in place, that give you a dictionary, both of your data and your data flows. And there at the bottom, you can see potential threats. Now, these are the potential threats that get automatically figured out from the description of the system that we just created, right? And what they look like is this. So this one is for privilege abuse. It will tell you which element is targeted by this threat. It will tell you what's an average severity. We are not calculating severities in here yet, but this is going to give you what's normally out in the field. If you find the privilege abuse, the average severity is going to be medium. It's going to give you an example instance. How does this thing happen in the wild? It's going to suggest mitigations and give you references going back to KPAC, to CWE, and other authoritative sources that you can go and learn more about it. Invoking PTM. So if you remember, as I said, pytm is used as a library. So basically you write your own script and then you call that script. Now, what pytm does, what that tm.process gives you, is this set of arguments. So if my script is called tm.py, I will call it tm.py and then my arguments. What you have is SQL dump, which is going to get your system and dump it into a SQLite database. And that's useful for a lot of people who want to move to different tools, reporting tools, things like that. Same thing with the JSON flag. It's going to create output in JSON. We have debug, which is obvious. DFD and sec, they create a data flow diagram or a sequence diagram. Report uses a template to create your final report. Exclude, sometimes you're not interested in some classes or in some instances of threats. So we let you exclude them from the final report by saying these ideas are not interesting to me. Sometimes you want to enter an element, but you're not familiar with the attributes that it takes. So describe, given an element, a class of elements, will let you know what the attributes are. List elements will let you know all the elements that are available. Levels is interesting because when we explain threat modeling, we tell people, hey, when you create diagrams, perhaps it's good to start with a top level, level 0, 30,000 feet look at the system, and then slowly go down. But we keep thinking about how do you keep those descriptions in code in a way that's manageable. So we came up with levels. You can specify that a specific element is only at a certain level, and then you can express the system according to those levels. And stale days is a sort of a new one. Remember that one of the targets that we have in here is to have developers do threat modeling. Not the big architect in the sky, not the great hero that we are paying hundreds of dollars an hour. We want developers to do this thing. And we think that it would be great if the threat model can be kept together with the code that it describes, right? Together with the system that's being developed. And maintained using the same source code repository tools and the same routine, and creating basically facts in the ground that if you fix the code, then you fix the threat model together. There are other systems out there that relate to source code and what it does in terms of threat modeling, but they work in different ways and different levels that we are not going to go into here. They have a lot of value. They work differently from pytm. So if anybody wants to look for them later, we got in the references some material. But stale days, basically what it's saying is, give me those files that are separated from the last time that they were updated by X days from the source code that they describe. So if you start seeing the stale days delta go up relentlessly, it just means that code is being updated and the threat model is not, or vice versa. Here's an example of calling pytm to create a diagram. And you'll notice that this diagram looks different from the ones that we presented before. The thing is, we want pytm to follow the Unix philosophy, to do the one thing that it's good at and only that. So pytm by itself doesn't know how to create diagrams, doesn't know how to build them or anything like that. It knows how to create files that can be consumed by tools that create those diagrams, which will probably do the job much better than we do. So here in the command line, you can see that I am creating a data flow diagram, and then I am passing it to another tool called dot and saying create a PNG and follow the rendering engine called SFDP. I could have chosen any of the other many rendering engines that dot supports, but I just went with this one for the example. And then we pass the output of that, which is a PNG file, to ImageCat, which is a tool from iTerm 2 that makes it easy to see graphical content in the terminal without opening a new window. So this is an example of pytm in use and how it pipes to other tools and how you can include it actually into your CI/CD or into your build routines to automatically create the threat model as your code evolves. It's an open source project, so we are inviting people to join us. We are also an OWASP incubator project. There is no need for previous experience, so even people who are not coders are very welcome. There are many good first issues available on GitHub for people who just want to dip their toes into the water. We have a passionate and supportive developer and user community. We are not exclusivist, and we don't tell people only come if you know what you're doing. And seriously, no idea is too crazy. We may wait to implement something, but we are definitely open to hearing any and all ideas that come up. So with that, thank you very much. Any questions?
Thank you. Thank you. Your presentation is very helpful for us.
Okay. And
Yeah, I think some of the students who are watching this, for them to make a career in that modeling, and we had we had few of the developers who were in between, like they were doing the day-to-day development for the companies, but then they are now also pursuing career in cybersecurity. So for them, this is a good place to be, where you can still pursue your development skills and passion, but same time you can contribute towards securing your organization, securing the business workflows. So this is right on the spot where you highlight, right? Everybody talks about using one tool or other just to do, say, pen testing or some primary assessment, but you have to go deeper into it. You have to know how those tools work. You have to be prepared to write your own Python script, and this way of automating it, analyzing it, is wonderful.
And
thank
our
you.
guests also in our audience, they have very wonderful comments and they like and
Yeah,
understand what you are presenting, even though they are not
yeah.
any developer.
Somebody on the compliance side, they are also happy that this is very helpful for access governance, because the analytics is not only about helpful in eliminating the cyber threats, but also from the security and compliance regulation perspective. This analytics and this work is very helpful to help the organization customize what they are looking for, first of all, because
And
all the time it's always a fight between the organization and the compliance manager, and the vendor. Hey, I don't have this, I don't have that anymore. But if a developer can write some of the scripts, some of the modeling they can do based on their own business apps they have, then it's wonderful. And thank you for sharing all the resources and being part of the OF's project. And thank you also, Matthew, to highlight the work that you have done. Also, we noticed that one of the contributor was the Betterman, who is also part of Rainbow Secure team, helping the businesses to stay secure. So it was very nice to have all three of you contribute on that project as well.
so I have a question about this book. So where can I get this book? Is it from Amazon or is
Sorry, the tool or the book?
Yeah,
book? This
the
Oh,
book, the
the
threat
book is
model.
on Amazon. Yeah,
oh,
Yeah,
Amazon. Thank you, Ravi.
yeah.
Or
and
Safari Online.
Safari
Okay.
Online. Yeah.
Safari Online. Okay, yeah, we can definitely get it for some of the students, and also
I
we can,
want to read that, so I definitely can have this book and read for myself.
yeah, we can. We also donate this book to the student community.
Yeah, sure. So, any question?
And surely, I think we will bug Matthew and Izar again for, because they give this wonderful presentations. And when you do the good work, we will also involve you in a threat modeling related project that we are coming up with, where there will be students, there will be a business founders who would be willing to give access to their infrastructure, to their workflows, and we can have a workshop kind of thing to actually do a practical hands-on thing.
Well, thank you for having us to present today. And any questions, feel free to reach out on Twitter, LinkedIn, however, to get a hold of us. We'll be happy to answer any questions.
Sure,
Thank
sure.
you.
And definitely, definitely, sure.
And our audience, if you have any question, please join after this session. We have a open networking area, so you can meet our guest on that.
Yeah, and we can also forward your questions to Izar and
Yeah,
Matthew.
sure.
And feel free to reach them out. Thanks
Yes.
again, Izar. Thank you, Matthew, for being here
Thank you.
and joining us. You
Excellent.
have
Thank you very
been
much.
teamed up very nicely.